All right, you are welcome again. Today, let's take a look at this question. Find the derivative of the function y is equal to x squared plus 1 in bracket raised to power sine x. All right, here we are given a function. We are asked to find the differentiation or the dy dx. Okay, now the first step, we are going to take the natural log on both sides, that is the ln on both sides. So taking the ln of both sides, we are going to have ln y is equal to ln x squared plus 1 in bracket sine x. Going with the law of indices or the law of logarithm, the power can be brought down. Okay, so it will come behind the ln. Okay, so here we're going to have ln y is equal to sine x ln x squared plus 1. Okay, so here we can go ahead and then find their proper derivatives. Now in the left hand side, for us to find the derivative of ln y, we are going to differentiate this ln y as if it is x, but because it is y, we multiply by dy dx. That is implicit. Okay, so for us to differentiate ln y, we are going to have 1 over y dy dx. Okay, now going to the right hand side, we have sine x ln x squared plus 1. So here we are going to apply product rule. So here we are going to differentiate sine x multiplied by ln x squared plus 1, then plus the derivative of ln x squared plus 1 multiplied by sine x. Okay, now let's find the derivative of ln x squared plus 1. Now in somewhere here, let's just say here, let's say let v equal to ln x squared plus 1. We want to find the derivative of this ln x squared plus 1. Okay, so what do we do here? Here we say let v equal to ln x squared plus 1. That means here we're going to find the dv dx of this. Okay, so from here we can simply say again, using chain rule, let this x squared plus 1 be called a letter. Now let's use letter u. Okay, so that means we say let u equal to x squared plus 1. Now if we call this x squared plus 1 a letter u, that means our v have changed to ln u. That means we say v is equal to ln u. Is that true? Yes. Now let's go to this function u. Here we say u is equal to x squared plus 1. All right, good. From this place we can say let's find the derivative of this u with respect to x. So that means we say du dx. So du dx is going to give us what? 2x. All right, good. And then let's go back to our v. Here we have v is equal to ln u. There is no x here, so that means we are going to find dv du, the derivative of v with respect to u. Okay, so the dv du here is going to give us 1 all over u. Is that true? Yes. But you discover that initially we are looking for the derivative of ln x squared plus 1, and we say that this ln x squared plus 1 is v. That means we are actually looking for dv dx. Okay, but the two derivative we have here now is dv du and du dx, but what we are looking for is dv dx. Now going with chain rule say that the v dx that we are looking for is going to be the product of the two derivatives we have already. So that is, we say dv dx is equal to dv du multiplied by du dx. Okay, so what do we have as our dv du? Our dv du is 1 all over u, and then our du dx is 2x. So multiplying this together, it gives us 2x all over u. But you recall that u is x squared plus 1. Let's replace it. So dv dx is equal to 2x all over x squared plus 1. Now look at this. We are actually looking for the derivative of ln x squared plus 1, okay? And we have found it to be 2x all over x squared plus 1. So now, we say the derivative of sine x multiplied by ln x squared plus 1. So the derivative of sine x is what? Cos x. Now we multiply by ln x squared plus 1. Then we say plus, okay? The derivative of ln x squared plus 1 multiplied by sine x. And then we see that the derivative of ln x squared plus 1 gives us 2x all over x squared plus 1. Then multiply by sine x is going to give us sine x 2x all over x squared plus 1. Hello. So when we say the derivative of ln x squared plus 1 multiplied by sine x is giving us 2x sine x all over x squared plus 1. All right? Yes. So that means differentiating the right hand side and the left hand side. We have 1 all over y dy dx is equal to cos x ln x squared plus 1 in bracket plus 2x sine x all over x squared plus 1. All right? Yes. In this place, we have 1 all over y. Let's remove the fraction, or let's remove the 1 all over y, because actually we are looking for the derivative of y, which is dy dx. So we multiply both sides by y. So multiplying both sides by y, we're going to have dy dx is equal to y, open bracket, cos x ln x squared plus 1 plus 2x sine x all over x squared plus 1. But you recall that from the beginning, we said that y is x squared plus 1, a bracket, raised to power sine x. Let's bring it back. So here we say that dy dx is equal to x squared plus 1, in bracket, raised to power sine x, multiplied by cos x, ln x squared plus 1, in bracket, plus 2x sine x all over x squared plus 1. All right? Yes, this is the derivative of the function. Thank you very much for watching. Please click the like button, subscribe if you have not, share our videos, and stay blessed.